This code imports the necessary libraries for data analysis and visualization. NumPy used for numerical operation and arrays. Matplotlib visualization tool for creating graphs. Usage areas model containing project-specific helper function. Copy used to create copies of objects. Math provides mathematical operation and constants. Matplotlib inline allows graphs to be displayed directly in Jupyter Notebooks dataset. This code is used to load two data setups. First, the load data 1 function reads the values from x1 data1.txt and separates the data into two columns. The first column contains the properties x1 and the second column contains the target variable y1. The second function load data2 reads the values from x1 data2.txt. In this file, the first column is separated into the properties x2 and the second column is separated into the target variable y2. As a result, the first data setup is loaded with xtrain1 and ytrain1, and the second data setup is loaded with its xtrain2 and ytrain2. This is a basic step for data analysis. This code is used to print the first 5 elements contained in the two data setups. First, we print the task type of xtrain1 and then we reveal the occurrence of the xtrain1 component. This shows whether the first dataset is an array or another type. Then we display the task first 5 elements of xtrain1 are and display the first 5 elements of xtrain1. So similarly, we print the task type of xtrain2 and display the content in the xtrain2 variable. Finally, we display in the task first 5 elements of xtrain2 are and display the first five elements of xtrain2. This code is used to check the values of two data sets. First of all, in the case of type of ytrain1, the content of the ytrain1 variable is not displayed. Then we display the first 5 elements by saying first 5 elements of ytrain1. Then we do the same for ytrain2. We don't display the visibility of type of ytrain2, and then we display the first 5 elements by saying first 5 elements of ytrain2 are. This code is useful for a quick understanding of two data sets and their data. This code checks the dimensions and number of examples in two data sets. First, it prints the shape of xtrain1 and ytrain1 showing their size. Then it displays the number of training examples is in xtrain1. Next, it does the name for the second dataset. It prints the shape of xtrain2 and ytrain2 along with the number of training example in xtrain2. This code creates a scatter plot using matplotlib. It uses the xtrain1 and ytrain1 datasets, displaying the points as a red X markers. The plot is typed profits population per city, with the y-axis labeled profit in $10,000 and the x-axis labeled population of city in 10,000. Finally, the graph is displayed with PLT point show visualizing the relationship between population and profit. The compute cost function calculates the cost of a linear regression model. It takes the input data x, actual outputs y, and parameters w and b. The function computes the prediction profits for each input, calculates the skew differences from the actual profits, and sum these costs. Finally, it arranges the total cost by dividing by 2m, where m is the number of training examples. This average cost is returned, helping to evaluate the model's performance. This code use the compute cost function to calculate the cost of linear regression model. It imports the NumPy library and defines the function, which takes input data x, actual values y, weight, and bias. To compute the cost, initial parameter values are set as initial w equal to 2 and initial b equal to 1. The function is called to compute the cost, and the result is print. Final tests from the public test module are imported to verify the correctness of the function. This helps determine the initial cost of the model. The compute gradient function calculates the gradients for a linear regression model's parameters. It takes the input data x, actual outputs y, and parameters w and b. The function determines the number of training examples m and initializations. The gradients dj, db, dw, and dj, db to 0. It iterates over each example, computes the predict value, and updates the gradients based on the difference between prediction and actual values. After average the gradients by dividing by m, it returns dj, dw, and dj, db, which are crucial for optimizing the model parametering using gradient descent. This code computes the gradients of linear regression model using parameters initially set to 0. First, the NumPy library is imported. The compute gradient function takes the input data x, actual outputs y, and model parameters w and b. It determines the number of training example and m, and calculates the gradients. The weight gradients dj, dw is computed as the average of the product of the difference between prediction and actual values multiplied by the input data. The bias gradient dj, db is calculated as the average of this difference. The initial parameters initial w and initial b are set to 0. The function is called to compute the gradient, and the results are print. Finally, task function from the public task module are used to verify the correctness of the compute gradient function. This process helps assess in the initial gradients for parameter updates in the model. All the tests passed. This code calculates the gradients for the w and b parameters of linear regression model using the gradient descent method. The compute gradients function finds the error between the model's prediction and the actual result, then calculates how much the parameters need to be updated. It uses initial values, test w equal to 0.2, test b equal to 0.2 to compute the gradients, and these values are printed. The gradients are then used to update the parameters and improve the model's accuracy. This code implements batch grading descent for a linear regression model. The function takes input data x and y, initial parameters w and b, cost and gradation function, learning rates alpha, and the number of iteration iters. In each iteration, it computes the gradient and updates the model parameters accordingly. Additionally, it logs the cost every 10 iterations and store the cost and update weights for later analysis. Finally, the function returns the update weights, bias values, along with the history of cost and weights, which can be used for performance evaluation and graphing. This code uses the gradient descent algorithm to optimize the weight and bias. Parameters of a linear regression model, the initial values are set to 0, and the learning rates and number of iterations are specified. The gradation descent function calculates the gradation at each iteration, updating the w and b values and recording the cost. Ultimately, the function is called to obtain the w and b values to achieve the lowest error rates, which are then printed to the console. This code implements linear regression using gradient descent. It starts with sample training data and initialization weights and bias to 0. The cost function calculates the mean square error, while the gradient function computes the gradient descent function iteratively updates the weight and bias based on the gradient and the specific learning rate. After the iteration, it calculates predictions using the optimized parameters and prints the result. This code performs linear regression using gradient descent onto dataset x1 data 1 and x1 data 2. It first loads the data and defines function to compute the cost and gradient. The gradient descent function updates the model parameter, weights, and bias iteratively. After training the models, it visualizes the actual versus predicts values using the scatter plots and fitting lines. Finally, it prints the optimized parameter for datasets, demonstrating the effectiveness of the gradient descent algorithms in fitting linear models. This code predicts profits based on population using linear regression. Data loading, it loads the x1 data 1.txt dataset into xtrain1 population and ytrain1 profit. Functions compute the cost, calculates the mean squared error, compute the gradients, computes gradients for updating parameters, gradient descent, updates weight and bias iteratively, model training, initializations, weights and bias, then train the model with gradient descent, predictions, calculates and prints predict profits for population of 35,000 and 70,000. This process demonstrates fitting a linear model and making predictions based on trained parameters. Thank you for listening.